All right, folks, buckle up, because today we're tackling a question that's been fueling science fiction forever. Can we actually break the speed of light? I mean, spaceships zipping across galaxies faster than light.
Hmm.
It's mind-blowing, right?
It really gets the imagination going, doesn't it? But before we get carried away with warp drives and all that, we got to understand why breaking the speed of light is such a massive challenge.
Okay, so let's start with the basics then.
Eh.
What exactly do we mean by the speed of light?
We're talking about a speed of, get this, 299,792,458 meters per second.
Whoa, okay, that's seriously fast. But why is that the ultimate speed limit? Like, is there some kind of cosmic rule we can't break?
You could say that. It's not a traffic cop or anything, but more like a fundamental law of the universe. It all comes down to Einstein's theory of special relativity.
Ah, Einstein, the big brain himself. So what does special relativity tell us about this speed limit?
Well, it says that the laws of physics are the same for everything moving at a constant speed. And the key here is this. The speed of light in a vacuum is constant for everyone, no matter how fast they're moving.
Hold on, I'm not sure I follow. So if I'm on a super fast spaceship, right, and I shine a flashlight, the light coming out of that flashlight is still traveling at the speed of light, even though I'm already moving super fast.
Exactly. It's not like adding speeds the way we normally think about it. If you toss a ball forward on a moving train, someone watching from the platform sees that ball moving faster than if you threw it standing still. But light always travels at the speed of light, regardless of how fast the source is moving.
Wow, okay. My brain's already starting to hurt. Why is light so different? Why does it get to break the rules?
It's all about space-time. This like four-dimensional fabric where space and time are all woven together. Think of it as this giant cosmic sheet. Now, objects with mass, they create a little dent in this sheet. And the faster an object moves, the more energy it carries, the bigger its mass gets. And that dent gets deeper.
So as an object gets closer to the speed of light, it's basically getting heavier and heavier.
Precisely. And to actually hit the speed of light, an object would need an infinite amount of energy to overcome its infinite mass. So basically impossible.
So Einstein's theory is like putting up a giant road closed sign in front of faster than light travel.
You could say that. But hold on, special relativity has another trick up its sleeve. Time dilation.
Ooh, time dilation. Now we're talking. What's that all about? Does time actually slow down?
It does, relative to someone who isn't moving. The faster you move, the slower time flows for you compared to someone standing still.
Okay, I need a real-world example. Something to make this click.
All right, let's talk about muons. These tiny subatomic particles that are created by cosmic rays hitting the Earth's atmosphere. Muons have a super short lifespan. But because they travel at speeds close to light speed, their internal clocks actually slow down, at least compared to us down here on Earth.
So their time is stretched out, and they can actually reach the ground before they decay.
Yeah.
That's wild. It's like they're time travelers or something.
It's a cool way to think about it. And it's not just the theory. Experiments have measured this time dilation, proving that time really is relative to how fast you're moving.
I'm starting to realize time is way weirder than I thought. But even if we can't break the speed of light, are there any sneaky ways around it? Like, can we bend the rules without actually breaking them? Yeah, it's like the universe set it this ultimate challenge, but maybe left a few secret passages hidden somewhere.
Well, there are some wild theories out there. Ideas that might let us get around the speed of light even if we can't actually go faster than it. One of the coolest is the idea of wormholes.
Wormholes. Now you're speaking my language.
Yeah.
Those are like shortcuts through space, right? Like in the movies.
Exactly. Imagine you've got a piece of paper, and that's space-time, right? And you want to travel from one side to the other.
Okay, I'm picturing it.
You could crawl across the surface, but that'd take forever. Or you could fold the paper in half and make a tunnel straight through. That's basically a wormhole. A tunnel through space-time connecting two faraway points.
So instead of outrunning light, we're making a shortcut. It's like finding a cheat code in the fabric of the universe.
It's a great way to think about it. If we could somehow make a wormhole or find one and stabilize it, we could travel crazy distances instantly without ever breaking the speed of light.
That's awesome. But are wormholes even real? Or are we just in science fiction land?
That's the million-dollar question. Einstein's theory of general relativity says they're possible, but we've never actually seen one. And even if they're out there, who knows if we could travel through them? There's just so much we don't know.
Okay, so wormholes are still a big maybe. What about other dimensions? Could those help us bypass the speed limit?
Now you're getting into some seriously mind-bending stuff. Some theories, like string theory, suggest there could be more spatial dimensions than the three we're used to.
Whoa, more dimensions. So there are like hidden dimensions all around us.
It's an idea.
Hmm.
Imagine a two-dimensional being, right?
Yeah.
Living on a flat sheet of paper. They can only move along the surface. But if they could access a third dimension, they could jump over obstacles and travel way faster.
So maybe we're trapped in our three dimensions, and there are higher dimensions out there that could hold the key to faster than light travel.
It's a possibility. But just like wormholes, accessing those extra dimensions is just a theory for now.
Okay, so wormholes and extra dimensions are still pretty far out. But hey, it's fun to think about. It makes you wonder what other crazy secrets the universe might be hiding.
Exactly. And even if we never actually travel faster than light, just trying to figure it out can lead to amazing discoveries. Look at all the cool tech we got from exploring space, things like GPS and new materials.
So pushing the limits of what we know, even if we don't find what we're looking for, can still pay off in unexpected ways.
Absolutely. Who knows what we might stumble upon in the process? And from a more practical standpoint, let's be real. The universe is ridiculously huge. Even at the speed of light, it would take forever to get anywhere interesting.
So if we want to really explore the universe, we got to find a way to deal with these insane distances.
Right. Faster than light travel, if it's even possible, would totally revolutionize space exploration. Think about it. Visiting other stars, checking out distant planets, maybe even meeting aliens.
It's like humanity's ultimate adventure, breaking free from our little corner of the galaxy.
Yeah, exactly. It's about pushing beyond our limits and seeing what's out there. But let's get real for a second. Faster than light travel, at least with what we know now, feels like a pipe dream.
Are we just chasing something that'll never happen?
Well, it definitely pushes the boundaries of our current understanding, but throughout history, we've accomplished things people thought were impossible. We landed on the moon, sent probes to other planets, built machines that can see atoms. Who knows what we can achieve in the future?
So you're saying we shouldn't give up hope just yet?
Nope. The history of science is full of ideas that seemed crazy at first, but turned out to be true. The key is to keep searching, keep learning, and keep an open mind.
That's a good point. But even if we never figure out how to travel faster than light, just exploring these concepts opens up our minds to the incredible possibilities of the universe.
You got it. It's all about the journey of discovery and the mystery of the cosmos.
Okay, I gotta admit, my brain is feeling a little fried after all this mind-bending stuff, but it's the good kind of fried, the kind that makes you want to learn more.
I hear you. It's fascinating stuff, isn't it?
Totally.
Yeah.
So, ready to dive into the really big question. What would it actually mean for us if we could travel faster than light?
Now we're getting to the heart of it. Let's explore those implications and see what new challenges they bring.
Okay, I think I've recovered from that last mind-blowing segment. Ready to tackle the big question. What would it mean for us if we could actually travel faster than light?
That's where things get really interesting, isn't it? It wouldn't just be about zipping around the universe quickly. It could totally change how we understand time itself.
Wait, are we talking time travel here? Like going back to the past? Because I've seen Back to the Future, and that could get messy.
You're not wrong to be cautious. Time travel is one of those mind-boggling possibilities that comes with faster than light travel. If we could somehow manipulate space-time to move faster than light, some theories suggest we might be able to go back in time.
Whoa, okay, now my head's really spinning. Wouldn't that create all sorts of paradoxes? What if you went back and accidentally stopped yourself from being born?
Exactly. Those are the kinds of paradoxes that make physicists scratch their heads. It really challenges our understanding of cause and effect.
So faster than light travel could rewrite the rules of time. That's a pretty big deal.
It is. And time travel is not the only crazy implication. It would also change how we view the size of the universe. Right now, we're stuck with the observable universe, the part we can actually see.
Because light from those places has had time to reach us, right? So we're trapped inside this little bubble because of the speed of light.
Kind of, yeah. But imagine if we could break free from that. With faster than light travel, we could explore places beyond what we can see now. We could expand our horizons on a cosmic scale.
Wow, that's like discovering a whole new world, but like a universe-sized new world.
Exactly. And it could change how we think about life in the universe, too. If we could travel huge distances quickly, we'd have a much better chance of finding alien civilizations.
Which brings us back to those ethical questions we touched on earlier. If we're zipping around to other star systems, we'd need to be really careful about how we interact with any aliens we might meet.
Absolutely. Faster than light travel wouldn't just be a technological revolution, it would be a cultural and philosophical one, too. We'd have to face some really big questions about our place in the universe, our responsibility to other life forms, the whole meaning of
It's
existence.
like humanity's ultimate test. Are we ready to handle that kind of power?
That's a question we'd have to answer together. But even thinking about these questions now helps us reflect on our values and how we want to approach our future as a spacefaring civilization.
So, can we break the speed of light?
Yeah.
And should we?
Based on what we know now, breaking the speed of light within spacetime seems impossible. But those theories about warp drives, wormholes, and extra dimensions, they suggest there might be ways around it. And who knows what amazing discoveries are waiting for us in the future.
Sounds like our quest to understand the speed of light is far from over.
Yeah.
Even if we never achieve faster than light travel, the search itself will teach us so much about the universe.
Exactly. It's a journey full of wonder and possibilities. The most important thing is to stay curious, keep asking questions, and never stop exploring.
Well said. And on that note, it's time to wrap up our deep dive. To everyone listening, if this topic blew your mind, keep digging. There's a whole universe of information out there waiting to be discovered. Read books, watch documentaries, talk to scientists, and never lose that sense of wonder.
The universe is an amazing place, and the more we learn, the more amazing it gets.
Until next time, keep looking up at the stars and wondering what's out there.